Here I have my polymorphic container data type again, and now two functions that go with it, a parseNum function and a parseString function. The parseNum function is one where I call parseNum with a number s expression that has a number inside of it, and it parses that number out and puts it in a container. And parseString does the same thing, but for strings instead of numbers. So here I got a container containing a string. ParseNum and parseString are very similar, and I would like to not repeat so much. You can see that the differences are the parseString versus parseNumber, and also that we use bin around s expression to string or s expression to number. One way I might try to reduce the copying here is just by putting both of these patterns into the same form. But now this isn't going to work. So even though I wrote container of alpha here, this alpha is a question mark. And the type checker can see, well, here we're creating a bin that has a number inside of it. So clearly we're returning container of number. But then it sees bin with a string, and so it complains number versus string. There's a mismatch. There's no one type that I can put here, and it can't be an arbitrary type because the function decides what to return, not the argument somehow coming in. So to make this idea work out, I have to do something slightly different. The source of the problem is that the function is constrained to one particular type by this function. So let's have the caller pass this function in so that they can pick what kind of parser it is. The caller is going to pick an sexp to something function. And this will be a function that takes an s expression, but gives an alpha back. And now if I use that function instead, then everything is fine. Right? Except that I forgot the colon in the syntax. But this will type check and run. Now I can do parse of a number and give s expression to number as the function, and that'll work. And I can do parse of a string and give s expression to string as the function, and that will work. What if I give it s expression to number, but I also give it a string type? Then we hit this case matching the string pattern, and we get an error because we can't convert it. And so really, this isn't quite what I wanted now. I have both cases inside the function where only one case makes sense for any kind of call to parse. So what I'm going to do, instead of having number and string patterns here, I'm going to let you pass in the pattern as well. So let's pass in the pattern. The pattern is just an s expression. And then we will match just that s expression. So now I can call parse when I want to work on strings, then I pass in string as the s expression. And when I want to work on numbers, then I pass number as the s expression for the pattern, and also number as the result. That way now I've written the parse function only once and just parameterized it over the parts that were different before, which is the pattern that we matched on and the function that converted a match to that pattern to some value to put in a container.